Hey everybody, let's spend a little bit of time talking about how to calculate the pH of some strong bases. And before we do that, we need to remember that water auto-ionizes. That's a common theme here with acids and bases, where we talk about water and how it forms hydronium ion and hydroxide ion. And that gives us a chemical relationship between the hydronium ion and the hydroxide ion, and that is Kw. Okay, now I don't expect you to know what Kw is yet mathematically or chemically, but I do expect you to kind of understand that when you multiply the concentration of the hydronium ion and the concentration of the hydroxide ion together, that you get the value of 10 to the negative 14. Now, for all you calculator buffs, realize that you're going to have to type that in your calculator as 1 times 10 to the negative 14 in order to get that in there correctly. But Kw is a constant. It will always be 10 to the minus 14. I've never seen a problem in my life where Kw was something different. So that's that. Now, the other thing to note is that just like pH is the negative log of the hydronium ion, or the hydrogen ion, pOH is the negative log of the hydroxide ions. Okay, pOH, negative log of hydroxide ions. And that's kind of neat because it's very analogous to the pH formula. And then the last thing is that when you add pH and pOH together, that gives us 14. And it's no coincidence that 10 to the minus 14 is Kw, and this 14 and this 14 are there. Okay, so it's not a coincidence. Mathematically, that all works out. But again, that's for later. But what this does is it gives us two ways to figure out the pH, and I guess I should have said of strong bases, because we could either calculate the pH and then figure out the pOH easier, okay, or using Kw, find the hydroxide ion concentration and then calculate, and then find the hydronium ion and then calculate all that, and that's harder. You can tell by the way that I was trying to explain it there. So anyways, let's move along. And so what this is gives you the kind of the box of calculating acid and base values. Okay, and so what I have done here, and I don't know why this is here. This pH should be here because we find pH. pOH should be here, pOH. And how do we find pH and pOH? Well, we can do it because we can do the negative log of this or the negative log of this. So here, these guys are related because 14 equals pH plus pOH. These guys are related because it's the negative log of the hydroxide ion, and this is the negative log of the concentration of the here I'll put hydrogen ion here, and these two are related because Kw equals the concentration of hydrogen ion or hydronium ion times the concentration of hydroxide ion. So everything is related, but notice you cannot go from here to here on our square. You can't go from here to here, here back to here. You have to go through this system, and this is convenient to kind of keep in mind for calculating pH. And this is going to help us down the line a lot. Okay, so let's keep moving forward and let's actually calculate some of the pHs of some strong bases. Now, this is going to be interesting because this is one of those things. Let me call up my calculator here. This is one of those things that it's like, oh, this seems pretty straightforward, and then all of a sudden there's a there's a monkey in the wrench. So Just like acids, notice that the amount of hydroxide ion is a 1-to-1 here. So for every 1 mole of this guy, we get 1 mole hydroxide ions. So this is a fairly straightforward calculation. To find the pH of this, what I'm going to do is I'm going to find the pOH, and that's going to equal the negative log of the concentration of the hydroxide ion. Okay, so I'm going to go negative log of the hydroxide ion, which is 1. Okay, and that's going to give me a pOH equal to 1. And I know that 14 equals did I say 1? That's a 0. Equals pH plus pOH. So that means that the pH equals that the pH equals 14. pH equals 14. Okay, now this one is kind of interesting because now what we have to realize is that for every 1 barium hydroxide, there are 2 hydroxide ions. So we have to do some calculating here before we can actually do anything to find the pH. We have to find the pH of just the hydroxide ion. Now this is strong, so what we know is for every 1 molar of BaOH2, we can X-line it. We get, for every 1 BaOH2, we have 2 hydroxide ions. How do I know that? Because that's what that tells us. Okay, again, we could do the same thing over here, but we know that it's a 1-to-1 ratio. For bases, sometimes we get these that give 2, and that's important to take into consideration. So now, if we really wanted to, instead of saying 1 molar, we could say 0.305 molar, and then we can go 0.305 times 2, and that gives us the concentration of hydroxide equals 0.610. And now we can do the negative log of 0.610, and that gives us that the pOH equals 0.215. And so that means that the pH is 14 minus that. So 14 minus that, and that's going to be 13.79. And so that pH is pretty high. Okay, so that's very basic. Again, doesn't tell us if it's a strong base, it just tells us that it's very basic. So now we continue. Okay, and so now let's see if we can figure out what the pH of the solution is. And so this is going to require us to know a little more chemistry than maybe what we have been talking about. Let me take my calculator, put it down here so that we can read this thing. And that says, a chemist adds 15 grams of sodium hydroxide to 100 milliliters of water. Okay, and it says, what's the pH of the resulting solution? Well, so pH is related to concentration. Concentration is molarity. Okay, and so this is kind of my thought process. pH is kind of related to concentration. The symbol for concentration is this like bracket thing, okay, with whatever. And then concentration, we need to get to moles because it's moles per liter. And so now we have to go back to our stoichiometry stuff. So we are going to say 15.0 grams of NaOH, and we're going to X-line this, and we know that the mass of NaOH is 40 grams for every 1 mole. So grams of NaOH grams cancel, and so we go 15 divided by 40, and that's going to give us 0.375 moles. And now we have to go to concentration. moles of NaOH. And so the concentration is moles per liter. It's 100 milliliters, so this is 0.100 liters. We move the decimal point over 3 spots. Okay. Remember that this value is the molar mass value. Okay, so now we take that answer and we divide it by 0.1. And so we get that this is 3.75 molar NaOH. So when we do that, now this becomes a problem like we just did. Okay, because all we need to do is calculate the pOH from that. So the pOH, I'm going to do this up here. The pOH equals the negative log of the concentration of hydroxide ion. And so we're going to go negative log of that. And there's that guy. So that means that the pOH equals negative 0.57. And so the pH is 14 minus that, which equals 14.57. So here's an example of where a base can be higher than 14, can have a pH of higher than 14. Okay, so there it is. That's pH problems, pOH problems, dealing with strong bases. I hope that helps, and have a great day.